It's the early 1990s, and suddenly Microsoft has a version of Windows people are actually willing to buy. Having spent most of the mid to late 80s producing versions of Windows that never really sold particularly well and, to be honest, weren't particularly good, Microsoft finally had a hit on its hands with version 3.0 of Windows followed by 3.1. However, there was a threat on the horizon. A number of parties had decided that they were going to push for the Windows API to become an open standard, policed by ISO. That would mean that any company could produce their own implementation of Windows, and applications that targeted the ISO standard API would just work on it. That would mean that Windows was no longer a proprietary thing that belonged to Microsoft, and Microsoft would not be able to pull some of the sneaky tactics it had done in the past, like a hidden API it used for its applications, to use its dominance in one space to acquire dominance in another. So in the early 90s, the fight was on, with Microsoft desperate to defend its commercial interest and everyone else trying to defend theirs. However, speaking of commercial interests, probably time for a quick word from our sponsor. Before we get into the nitty-gritty of how this all happened and came about and the battle for the standard. The sponsor of today's video is PCBWay, fine purveyor of printed circuit boards. Or at least that's a very big side hustle for them when they're not sponsoring half of YouTube. Yes, design your circuit board, upload the files, give them some money, circuit boards come back in the post. If you give them even more money, the circuit boards can come back with some of the components on them too. They also do 3D printing, CNC, injection molding. Basically, they seem to be going for, if you can design it and upload it, they can send you the physical object back in the post. Like many of the tales I tell on this channel, I'm going to begin this story with Sun Microsystems, the workstation people. Or at least they were until they became the dot-com bubble people, followed by the enterprise-class system people, and then the getting bought and destroyed by Oracle people. That bit's a little bit sadder. Now, in the late 80s and the early 90s, if you were at a company and you were using a workstation environment, that thing pretty much was going to be a Unix workstation, and most commonly a Unix workstation made by Sun. Don't get me wrong, there were lots of IBM-compatible PCs kicking around in businesses, but most of those ran DOS, and didn't have a GUI and didn't really class as a workstation. Sorry, Apple users, you were just in kind of the odd niche inside a business at this point. Now, your average Unix workstation cost a lot more than, say, a PC, for example, and they typically had a lot more processing power and a lot more RAM. But very importantly, they had a fully functional GUI in the form of either OpenWin or CDE slightly later on, or some of the more proprietary environments that we're not going to get onto in this video. And there were a fair few vendors kicking around making applications to run on these Unix-based workstations, usually with X11 in there. And plenty of vendors and applications you would have heard of to this day. For example, Photoshop, available for Sun, available for IRIX, and almost every other Unix, in fact, WordPerfect, as well as lots of scientific and mathematical applications like MATLAB or Mathematica. There were also a ton of very niche industry sort of products, various CAD and 3D modeling tools, for example. But a lot of the applications you'd later see running on Windows, they were all available for Sun, so CorelDRAW, etc. And at this point in time, Sun were doing very nicely, thank you very much. It was selling its relatively high-priced workstations, and it was selling them in volume. And Microsoft had been working on a GUI for the PC for quite a while, as had a number of other companies, and we'd had products like Windows 1, which was awful. I can't tell you just how awful that thing was to use, and they followed that up by Windows 2, which was better, in the sense that it's better to be run over by a motorbike than it is to be run over by a 20-ton truck. But neither one would you describe as a good experience. IBM had TopView for a little while, which was actually surprisingly alright, but commercially not very successful. And also there was Gem Desktop as well, which, that existed. So your Unix workstation vendors, including Sun, really didn't have a lot to worry about. Sure, the PC was outselling them quite a lot, but their devices were a lot more profitable. There was a higher margin on them. And they figured they could let the PC market sort of take care of a bit of word processing and spreadsheet and the odd thing here and there. And they could keep their nice high-end niche. The problem for them is, however, Windows 3.0 came out, and that became good enough to use. And suddenly, this little PC desktop is starting to dominate businesses a lot more because PCs outnumbered Unix workstations by a non-trivial amount. And this became a problem for the likes of Sun because the focus of application developers, like Adobe or Corel, started to become Windows rather than Unix. You also have businesses deciding for the first time that Some users who they thought warranted a workstation, well, now they could give them a Windows PC instead. And Sun, who were primarily a workstation company at this point, realised that this was going to eat into their market, if not today, then someday soon. Now, they'd already dipped a toe into the market of some PC compatibility. I mean, they ported Solaris over to run on the PC, but also they produced something called Sun PC for their machines, which was essentially, in at least its first release, a 486 on an S-Bus card that you could install inside your workstation, and that would let you have a window inside Solaris that you could run DOS and Windows 3.1, etc. in. Now, this was a solution, but it's kind of like running a virtual machine, only, sat on top of a non-SPARC based processor. And this is where Sun decided to acquire a chunk of technology from a company called Praxis Systems that it would call Wabi, which when pronounced correctly is the Japanese word for harmony. It also stood for Windows Application Binary Interface. Now, this chunk of software would let you run Windows applications directly on your SPARC machine without the need for any add-on CPU card plugged into your S-Bus. Now, this is Sun's first proper toe into doing this, and what Wabi did was replace a couple of the core components of Windows. So, for example, kernel.dll got replaced, and that's the bit of Windows in the Windows 3.1 day that dealt with all the memory allocation and access to devices. So that was rewritten so it'd make all the calls to Solaris to do that stuff. So, for example, you wanted to allocate some memory to something, well, the application would call kernel.dll, and that in turn would call the relevant Unix API to get some memory allocated, which it'd then hand over to that application. And of course, all that code was compiled for SPARC, so when you're doing all of that stuff, it's all running in native SPARC code. They'd also replace user.dll, and this is what the application's all called to do GUI type stuff like give me a window, add a menu to it, do this icon here. So all the UI drawing code again would all be in native SPARC and call the relevant X11 calls. And the final set of drawing APIs it would replace is GDI.dll. And this was used by Windows applications to draw stuff on the screen that were not really standard windowing components. So, for example, you wouldn't draw a menu with it, but if you were, say, MS Paint and you wanted to let people draw on the screen, well, then you call GDI. And again, that implementation was all in native SPARC code and would target the X11 calls that were needed to draw that stuff on the screen. Now, of course, Windows has a lot more APIs in it than just that. So, once you installed Wabi, like you can see me doing here, you would then have to take a copy of Windows and install that into Wabi with its custom installer, and it would take all the other Windows components that were not kernel, user, or GDI and install those in. Now, because that's all just the normal Windows stuff, none of that is compiled for SPARC. So there's a dynamic recompiling tool in here that takes x86 code and dynamically recompiles it for SPARC. And it also caches the output of that, so it doesn't have to do it more than once. So eventually everything in Wabi becomes SPARC code, but sometimes you'll see a bit of a pause in your application while that dynamic recompilation is taking place and then executing the code. And then when you try and recreate that pause, well, it won't, because it's already dynamically recompiled and doesn't have to do that again. But to be honest, those pauses are barely noticeable. So what we've got here is an incredibly good way to run Windows applications on a Solaris machine. In fact, Wabi did get ported off to other platforms as well, including eventually Linux by Caldera, who would eventually get purchased by SCO and evolve into being a patent troll. Now, I believe if you had a Sun PC card, also it just passed the x86 code directly to the processor on that card, and skipped the whole dynamic recompilation phase. But to be honest, my experience of Wabi is it really didn't need that, even on a, relatively modest Sun workstation, as even a relatively low-end 32-bit SPARC was somewhat more powerful than Intel's then highest performing 486. Now, this would change when Intel released the Pentium, and especially faster clock speed versions of the Pentium with working floating point. But we've not quite hit that point yet. Now, despite the cleverness of Wabi's approach to doing all of this stuff, there's a couple of flaws in there. Firstly, you need to buy a copy of Windows. So, in order to avoid using Windows on a PC, you have to buy a copy of Windows, which might lead organizations into thinking, why don't we just run Windows? Secondly, why the vast majority of Windows software worked on Wabi perfectly fine? Not everything did. Some stuff didn't quite function perfectly, or in some cases, kinda just crashed. Now, this was by and large down to the fact that Wabi's implementation of kernel user and GDI DLLs were not absolutely perfect. And this is because Microsoft documented some, but not all, of the features in those things. And Sun was always going to have to play catch-up whenever Microsoft decided they wanted to modify one of those three things. Now this is one of our motivations for the whole open standard that this video is about, but it's not the only one. Sun probably wouldn't feel the pressure if it had not been for the fact that Windows was not only snapping at its heels, but for the Trojan horse that was Microsoft Word and Excel. For years, the dominant word processor had been WordPerfect, and from a spreadsheet point of view, probably Lotus 123, both of which were available for Unix. So this meant that users that were word processing on a DOS machine could easily exchange files with people who were working on the Unix workstations. And while you might be using your Unix workstation for some programming task or some engineering or scientific task, more or less everyone in an organization has to engage in some form of word processing here and there to produce documents to exchange with each other or to read documents that others have written. Remember, PDFs aren't really as popular at this point. Now, all of this was fine in terms of an interoperability between DOS and Unix thing. However, then comes Windows being popular, and with it, Microsoft Word and Excel for Windows, that just became known as Word and Excel. Now, those started to really displace the likes of 123 and WordPerfect, and there were a couple of reasons for that. Initially, the likes of WordPerfect had a bit of a shaky start, going from a more text UI kind of environment to a GUI type environment. Same with 123 to a lesser extent. But also, this is where Microsoft had been quite sneaky. You see, there were APIs in Windows that Microsoft didn't tell anyone who was not part of Microsoft about, and they're the ones that Word and Excel used, and they ran quite a bit quicker than the official APIs that WordPerfect and 123 had used. And therefore, users of Word and Excel got a much faster, snappier, low latency experience than users of WordPerfect and 123. And this meant that those once dominant applications, well, weren't that dominant on Windows, and then soon Word and Excel were very much dominant on Windows. And Word and Excel were not available on Solaris. So this meant that you suddenly had the majority of users on PCs producing stuff that Sun SPARC Workstation couldn't open or read or indeed edit. And this basically started Trojan horsing Windows into various bits of the business that, well, had not been Windows-based before, and suddenly you had people who had a PC on their desk running Windows and their Unix workstation, hence Sun feeling quite some urgency around Wabi. Now, you did soon find that the other word processor and spreadsheet packages started to try and gain compatibility with Word so they could open their files, and the same with Excel. But in these early years, that was far from perfect, and also, those file standards kept changing with each release of Word and Excel, so their competitors would always struggle to read and edit those files, which became part of a deliberate strategies of Microsoft to keep competitors out. Now, Sun did also get involved in that game and bought a company that produced Star Office and tried to make that as compatible with Word and Excel as they could, and to be honest, it didn't do too bad a job, but it did always lag a version behind. Some would eventually open up Star Office, and that would become OpenOffice, followed by the fork of LibreOffice, which, to be honest, a lot of us still use today, particularly if you don't want to pay a continual subscription to Office 365 for a word processor. Now, all of this led up to Sun identifying that there was an issue with Microsoft using the control of its proprietary standards to shut out any competition. So Sun proposed, let's turn the Windows API into an open standard. This would make it a lot harder for Microsoft to use control over the standard to keep competitors out of the market. Versions of Windows or the Windows API implementation could then equally compete with each other. And you can also see how that would have been quite an advantage to, well, us consumers as well. Now, Sun started referring to the standard as PWI, the Public Windows Interface, and it helped form the consortium with the likes of HP, Novell, IBM, although IBM were probably coming at this from an OS2 point of view, with the idea of turning the Windows API into a publicly available open standard that anyone could implement. And they started approaching a number of open standard bodies. One of the first they approached was XOpen in the February of 1994, who unfortunately rejected the effort after they were threatened by Microsoft, who was saying that this was their intellectual property. Now, we have in subsequent cases established that you can't assert intellectual property over an API, which is what happened when Sun's eventual owner Oracle tried to sue Google over some Java APIs in relation to Android. But to XOpen at the time, these threats from Microsoft seemed, well, credible, or credible enough to stop moving forwards with this as an open standard. It would seem, however, that the European Computer Manufacturers Association, the MCA. You may know them from the people who do the standardization of JavaScript. Well, it turns out they had slightly more courage than Xopen and decided to plow ahead with the standardization, despite Microsoft's intimidatory tactics. Now, this was perhaps a little worrying for Microsoft because the ECMA, unlike a whole bunch of other standards organizations, do actually have some teeth. Well, kind of. You see, if the ECMA produces a standard for something and you decide you're not going to follow it, well, that effectively blocks you from selling stuff to any European government or governmental organizations. And while in theory that doesn't stop you from selling to the rest of the market, it does make it difficult to sell to people who supply to governmental organizations or governments, which is where, a lot of the big bucks are. Now, the ECMA, they took this proposal of a standard to ISO, the International Standards Organization, and it was agreed that, they'd work on this standard, and this would become ECMA 234, also known as APIW, or Application Programming Interface for Windows, which became fast-tracked to become the ISO standard. Now, by this point, we've gotten to 1995, and this is where the Microsoft delaying tactics kick in, and also market changes start to occur. Let's start with the delaying tactics. Microsoft essentially goes down this claiming its intellectual property route again, and this actually manages to delay getting the standard ratified until 1997, which of course delays it enough for, distribute a lot less commercial interests to those who are trying to turn this into a standard, because between 1995 and 1997, out comes Windows 95 and the Win32 API. Now, the Win32 API, not part of this proposed standard, it's working on the Win16 API. So a lot of application vendors have swapped over to using Win32, but also for the likes of Sun, HP, IBM, etc. who are defending a Unix workstation market, there's not so much of a Unix workstation market left to defend. Sun and SGI are still really the only ones that are still in there. SGI is doing its 3D hardware accelerated thing, and Sun is still trying to sell its generalized Unix-based desktop. Sun also has a brand new strategy for how to get applications developed for both Windows and Linux in the form of Java, and its write-once, run-anywhere model, including Macs, and RISC OS if you don't like to do floating point. But even for Sun, that desktop market is starting to wane. But Sun maybe aren't quite so concerned about that, as while its desktop market is starting to wane, we are really starting to get into the dot-com bubble at this point, and Sun is entering one of its most profitable phases where it's basically selling all the server hardware to all these businesses that are about to either take over the entire of retail or go spectacularly broke. So for Sun, declining revenues from the desktop business are being so significantly offset by their server business that Sun as a company effectively reorientates itself towards the server market, to the point where they eventually even give up with their own desktop environment and start just shipping GNOME with their machines, before just stopping manufacturing workstations altogether. So with Sun, HP, IBM, etc. all effectively transitioning out of the workstation and desktop market, by 1997 there is not a lot of focus to drive along the standardization process. So when ISO have eventually cleared all of Microsoft's objections and announced that they're moving forwards on the standardization process, we don't seem to ever actually get to the point where we have a finally ratified standard from ISO. The effort just seems to quietly halt. Now, I should say, while all this standardization effort is going on in the background, Sun don't just halt what they're doing. In fact, there's quite a lot of development in the world of Sun. For a start, we go from the Spark processor to the Ultra Spark processor, leaping from 32-bit to 64-bit, as well as a number of instruction improvements as well. However, Windows doesn't sit still either. Intel finally get the Pentium processor out the door, which is a huge leap forwards in design and complexity. But that big leap forwards in terms of performance for PC processors means that even though Spark has come on leaps and bounds, emulating a Pentium and hitting the same sort of performance as a real Pentium is a lot more trickier thing to accomplish. Also, we then have the release of Windows 95, and running the Win16 API really well, that's not as important as it used to be, as 95 introduced the Win32 API. So Sun decides to stop Wabi as a project, because the approach it took isn't really going to work for Windows 95 in the same way. Sun decided to go with something called Sun PCI, lowercase I, and this is essentially reverting back to the same approach they took with Sun PC, in that what we have is a hardware card that's got an x86 compatible processor on it, in this case it's an AMD, But now it also has its own graphics chip and memory on the card as well. So what we effectively have is an entire PC on a PCI card that we can plug into our workstation. Yes, this is also the same time that Sun moved from SPARC to UltraSPARC and stopped using the old S-Bus interface from the Sun workstations and moved to using PCI. And all of that gets introduced with Sun's brand new Ultra 5 workstation, like the one I've got here. And effectively you just fit the PC on a PCI card inside your workstation, and there's an application you add into Solaris that essentially does what Sun PC did again and give you a PC in a window. But this means you can run Windows 95 or 98 at pretty much full native speed, whilst also having it all fit within your Solaris desktop. I mean, cost-wise, it's not ideal. You're buying a high-end Sun workstation and essentially paying for an extra cheaper PC to throw inside it. But Sun does well enough that we actually get quite a few revisions of this card. The one I've got here is one of the earlier versions, but it was still a pretty good spec for the time, targeted at running Windows 95 and Windows NT, with a 400MHz AMD CPU and 256MB memory. But Sun really just intended this for running applications. In fact, if you wanted to run a game on this thing that used DirectX, well, you wouldn't be able to view it via the desktop application for Solaris. You would have to couple a second monitor up to the SVGA port on the card and get your output that way, which for me, personally, is a little annoying. In the business environment that this was intended to be sold to, I doubt anyone ever actually noticed. Sun would keep developing this card for at least 2 more generations, so we'd eventually end up with a 1.6GHz version, and official support for Windows XP, Windows 2000, Windows 2003 Server, and of course, Red Hat's desktop version, and eventually Red Hat Enterprise version 3. Sun themselves would transition from making UltraSPARC based workstations to ones based on AMD 64, as well as AMD 64 servers. But while they were producing those AMD based servers, they would also keep making increasingly more expensive and larger UltraSPARC based servers, until Sun would just exit the workstation market altogether. So, what happened to the idea of opening up the Windows API so other people can implement it? So, Microsoft may have won the day and managed to keep it as a proprietary standard, after the ISO effort just sort of ran out of steam. But despite Sun effectively giving up on Wabi, other efforts to implement the Win32 and Win16 APIs on top of Unix, well, have continued. Thanks to the world of open source, we have Wine, which stands for Wine is not a Windows emulator. Yes, recursive definitions, always fun. Wine for decades has given us quite a good layer of compatibility and allows us to run a number of Windows applications on top of Unix, well, mostly Linux these days. But of late, thanks to the involvement of Valve, the people behind Steam and the Steam Deck, we now have Proton, which they co-developed with Codeweavers as a DirectX implementation for Wine, which now means I can basically buy more or less any game from Steam and just, well, run it on my Steam Deck and not worry about the fact that my Steam Deck's running Linux and not Windows. So while we may not have ever got the open standard that Wabi seemed to be the beginning of, we do have something that in practice has achieved the goals of Wabi. We have virtually all the APIs for Windows implemented on top of a Unix stack. And while Microsoft may still have proprietary control over what that standard is, a lot of game devs now test their games to check that they work with Wine and Proton so that it will just work on the Steam Deck. And the desktop isn't quite the dominant force it once was. We all have different classes of device that we use to do our computing, be it tablets, smartphones, even our TVs and occasionally the odd washing machine. It's been quite a while since Microsoft's made most of its money from its control of the Windows standard. These days, it makes most of its money from operating Office 365 and Azure mostly runs Linux. In fact, Microsoft ported their Hyper-V hypervisor platform to Linux and now runs Linux on most of their nodes inside Azure, which of course then run customer workloads that are mostly Linux. In fact, Microsoft even has a Linux distribution they use internally now that's their own. Although I think that's mostly targeted at their switches that also run Linux. It's kind of getting to the point where you wonder if in 10 years' time, will Microsoft actually still be making Windows, or will it put its effort into getting backwards compatibility as good as it can with Wine and just shipping Linux? After all, Microsoft was only ever in it for the money. So Windows could in fact one day still yet become an open standard, albeit one that's effectively defined by Wine. Well, I hope you enjoyed our wander through the history of the Windows API trying to become an open standard, and I'd like to say thank you very much for watching. I dare say quite a few of you may have opinions or comments, because whenever you discuss topics like these, yeah, people tend to have fairly strong feelings. So as ever, the comment section is open below for you to discuss. Please be nice to each other. If you enjoyed the video, there is that thumbs up button YouTube have put in place so you can indicate that fact, and likewise there's a button if you didn't feel that way. Thank you for the engagement. And as ever, if you'd like to help the channel out, please hit that subscribe button, because it does make a difference to whether the YouTube algorithm can be bothered telling people that this video actually exists.